Good evening, students. So in this class, we are going to continue with chemical equilibrium JEE NEET questions. That is question number 11 to 20. In the previous class, we have done 1 to 10. Observe question number 11 and try to solve this. For the reaction CO plus Cl2 gives COCl2, they are asking the ratio of Kp to Kc. So equilibrium constant at partial pressure by equilibrium constant for the concentration. So options are there, try to solve this. So what is the relation here? Kp is equal to Kc into RT power of delta Ng. So what is delta Ng here? As you are aware, delta Ng is nothing but number of moles of gaseous products minus number of moles of gaseous reactants. So this already we have discussed. Now in this, how to calculate? What is the equation? CO plus Cl2 gives COCl2. So we need to apply formula. So if you consider delta Ng, how do you get delta Ng here? You can see that number of moles of product 1, and if you consider the reactants, it is 1 plus 1, nothing but 2. So therefore delta Ng is equal to 1 minus 2. So what you get? Minus 1. Substitute delta Ng and find out what we get. Kp is equal to Kc into RT power minus 1. We want the ratio, therefore send Kc to the other side. You get Kp by Kc is equal to RT power minus 1. You can observe here it is also written as 1 by RT. So answer is A. Hope you have understood this. Copy the solution and let's move to question number 12. Next, question number 12. Equilibrium constant for N2 plus O2 gives 2NO at temperature T is 4 into 10 to the power of minus 4. Now they are asking find out Kc for this reaction. See, the same reaction they have changed it and they are asking the value of Kc. This was asked in AIEEE 2012. So you know that if at all a reaction is reversed, what is the condition? We can write like this: K dash is equal to 1 by K. Suppose another condition, what is that? If coefficients are reduced to half, we know that K dash is equal to root K. So this is the formula what you have to apply here. Now consider this, what is happening to this reaction. First and foremost thing, 2NO is being converted into NO. That means both the things happened here. What is that? The reaction is reversed like this. We can write like this: 2NO gives us N2 plus O2. So the reaction is being reversed. Later what they have done, so if reversed means you know it is 1 by K, and they have reduced the coefficients to half. Hence what we can write? We can write like this. So K dash is equal to 1 by root of Kc. So this will be your formula. Now find out. So what is Kc here? 4 into 10 to the power of minus 4. So K dash is equal to 1 by root of 4 into 10 to the power of minus 4. So what is your answer? 1 by root 4 is 2. Root 10 to the power of minus 4 is 10 power minus 2. Let us take it to the numerator. We get 10 square, nothing but 100 by 2. So we get 50. So what is the answer here? Answer is 50. Hope you have understood this. Very simple. Two conditions we have applied and found that K dash is equal to 1 by root of Kc. So on calculation you got Kc value is 50. Hope you have understood this. Let's move to question number 13. Next, question number 13. Which has greater active mass? So 4 options are there. 200 grams of limestone in 2 liter vessel, 56 gram N2 gas in 0.5 liter vessel. Third one is 90 grams CS2 liquid. So if you observe here, both the limestone, that is solid, and here you are having liquid here. CS2 is in liquid condition. So active mass, already you are familiar with this. What is that? If at all you are taking active mass of solid and liquid, generally you consider it as 1. So these two you already know the active mass. So we need to calculate B and D. So what is given for this? If you take option B, 56 grams N2 gas in 0.5 liter vessel. So what will be the formula here? Active mass is equal to number of moles by volume in liter. So volume in liter. So number of moles by volume in liter. So how do we calculate number of moles? Mass by molecular mass, you know, right? So what is the mass given? 56 grams. So 56 by molecular mass of N2, 14 plus 14, nothing but 28. Divided by volume is given as 0.5 liters. We can take it as 1 by 2 also, or 0.5. Now if you calculate this, 28 ones and 2, so that is equal to 2 by 1 by 2. So if it comes to numerator, you get 2 into 2 by 1, hence we get 4 molar. The concentration is 4 molar. Earlier here it is, if you can write here 1 molar, this is also 1, and here you are getting 4 molar. Now the last one. So 1 mole of the oxygen gas is given. So we can write like this. So N by V. How many moles? 1 mole. And volume, you know that if at all you are taking STP, or any gas at STP occupies 22.4 liters. Therefore we can write like this. Hope we have understood this. 1 mole of any gas at STP occupies 22.4 liters. Hence volume is 22.4. So we can write like this. Directly you can write 1 by 22.4 molar. So this will be least one. Now which is the highest here? 4 is highest. Hence we can take answer is this. Hope you have understood this. Very simple question. Let's move to question number 14. Next, question number 14. They have given, in a chemical equilibrium A plus B gives C plus D when 1 mole of each of 2 reactants are mixed. So they have taken 1 mole of reactants. So you will get 0.6 mole of the products. Find equilibrium constant Kc. So first let us write the equation here. A plus B gives C plus D. Now what is given? Initial concentration. So 1 mole each, and products are not formed, therefore 0. So concentration at equilibrium. So they have mentioned here 0.6 mole of products are formed. So let us write like this: 0.6 and 0.6 of D. What will happen to this? You know, 1 minus x. If it is x, it is 1 minus x. Therefore you can write 1 minus 0.6. And for B also 1 minus 0.6. So what you get here? 0.4, 0.4 and 0.6 and 0.6. Apply the formula Kc, the concentration of the products by concentration of the reactants, nothing but C into D by concentration of A into concentration of B. Substitute the values, what you get? 0.6 into 0.6 by 0.4 into 0.4. So nothing but 6 36, so 0.36 by 0.16. So you can cancel this. So 4 fourths and 4 nines you can take, nothing but 2.25. So we get the value of equilibrium constant as 2.25, nothing but option C. Hope you have understood this. Copy the solution and let's move to question number 15. Next, question number 15. Calculate concentration of H2, I2 and HI if 0.04 mole of HI is placed in 1 liter flask at 430 degrees. They are asking the Kc, like we will calculate all the concentrations, but what is given here? For another reaction, H2 plus I2 gives 2HI, Kc is 54.4. So they have given this one. So I have solved this for you, half of the question I have solved. So in this we have H2 plus I2 gives 2HI, Kc value 54.4. But they are saying here that 0.04 mole of HI is placed in the vessel. That means decomposition. So they have given Kc value for this, but another reaction, what is that? Decomposition of HI equation is this. For this, how do we calculate? As you are aware, the formula, if you reverse any equation, that is equilibrium, what will happen? K dash will be 1 by K. Hence, we can write it as the equilibrium constant for our equation is 1 by 54.4. Hope you have understood the first step. Next, follow the usual method. We write initial concentration. How much is given? That is 0.04 mole initial concentration for HI. So products are not formed, hence 0. And at equilibrium, what is the concentration? Let us take H2 as X, I2 as X. Because you know the coefficient is 1, you take it as X. If coefficient is 3, you take it as 3. Now, what about this? It is nothing but 0.04 minus X. Next, apply the equilibrium constant formula. Nothing but the concentration of the products divided by the concentration of the reactants. You know that the reactant here coefficient is 2, hence it is HI square. Substitute the values here, you know, K dash is 1 by 54.4 and value of this is X. So X into X is X square and HI is 0.04 minus X. So we have square here. Hope you have understood this. Now what you will do is, because it is having square, instead of calculating this, send the square to other side, it will become square root. Therefore, 1 by root 54.4 will be X by 0.04 minus X. Very simple. Here what we have done, because you are having square, send it to other side, it will become root. So you will get the value here 0.1356. Next, cross multiply. What you get? X is equal to 0.1356 into 0.04 minus X. So I have solved this. So finally what you get? The value of X is 0.00427. So molar. See, actually you got the answer here. You can stop this question and mark this. But to confirm that whether HI concentration is 0.0315, we will move to the second step. Hope you have understood the first part where you got the concentration of H2 and I2, nothing but X. Now to find out the concentration of HI, see, we have this concentration of HI is equal to, you know the value of X, 0.00427. So let me write like this, number of moles 0.4 minus X. So this was the formula to calculate the concentration of HI. Now what is X? 0.4 minus 0.00427. So you can solve this, and what you get, you will get the answer as 0.03146. Molar you can change it into 0.0315 molar. Hope you have understood this. We got concentration of H2 and I2 as well as concentration of HI. Now let's move to question number 16. Next, question number 16. The equilibrium constant for this reaction, H2O liquid plus CO gas, gives H2 gas plus CO2 gas is 64. So they have given the value of Kc and they are asking, if rate constant of forward reaction is 160, what is the rate constant of backward reaction? See, we know the formula that equilibrium constant is equal to, we can write like this, rate constant of forward reaction by rate constant of backward reaction. In short, you can write like this, Kc equilibrium constant is nothing but K. If you write forward, small f divided by Kb. This is your formula. So you are having equilibrium constant 64 is equal to, what is the rate constant of forward reaction? 160 by kb. They are asking you to find the rate constant of backward, so send this to other side. What you get, kb is equal to 160 by 64. Let us use 16, so 16 tenths, 16 fourths. So what is your answer? 2.25. Therefore rate constant for backward reaction kb is equal to 2.25. So hope you have understood this very simple formula. Equilibrium constant is equal to rate constant of forward reaction by backward reaction, nothing but kf by kb. So 2.25 you can take it as 2.5. So 4. So 2.5. Hope you have understood this. Let us move to the question number 17. Next, question number 17. At equilibrium, the concentration of N2, O2 and NO is given. So the reaction was carried out in a sealed vessel at constant temperature. Now they are asking, find out the equilibrium constant for this reaction, that is N2 plus O2 gives 2NO. First and foremost thing, write down the equation. N2 gas plus O2 gas gives 2NO gas, and write the given information. What is that? So the concentration at equilibrium, so they have mentioned the concentration directly at the equilibrium. N2 is 3 into 10 power minus 3 molar, O2 4.2 into 10 power minus 3 molar, and NO is 2.8 into 10 power minus 3 molar. And we know the formula, Kc is equal to the concentration of the products raised to the power of coefficient divided by concentration of reactants. So we can write like this, concentration of NO square by concentration of N2 into concentration of O2. Why we wrote square? Because coefficient of NO is 2. Substitute the concentrations here. So given concentration of NO is 2.8 into 10 power minus 3. So square, hence we can write it as 2.8 into 10 to the power of minus 3 again, divided by N2 is 3 into 10 power minus 3 and O2 is 4.2 into 10 to the power of minus 3. Hope you have understood this. A very simple thing. If you know the formula for equilibrium constant, they have given you the molar concentrations at equilibrium, so easily you can substitute. Now calculate this, cancel 10 power minus 3 here, and now I have already calculated and got the answer as 0.622. So you can also check with the calculations. So the value of equilibrium constant Kc is 0.622. So copy the solution. Hope you have understood this. Let's move to question number 18. Next, question number 18. They have given if K1 and K2 are equilibrium constant for the following reactions. That is, first one, HCF6 gas plus water gives XeOF4, that is gas, this is steam, plus 2HF gas. Equilibrium constant is K1. For the second equation, XeOF4 plus XeF6 gives XeOF4 plus XeO3F2. The equilibrium constant is K2. See, the question looks little bigger, but solution is very simple. Now they are asking, find equilibrium constant for this equation. So they have given another equation. So what you need to do is, you have to convert the equation 1 and equation 2 in such a way that you will get the required equation. So options are there, K1 into K2, K2 by K1, K1 by K2 square, and last one is K1 by K2. So let's start the solution. Hope you have got an idea. Even in thermodynamics also we have done similar type of questions. Observe here, if you see XeO4 fine. So what you have here, you can just check it out. Here it is XeF6, then H2O, the other side XeO4, and then 2HF. So you have to observe this and convert this 2HF. So this is XeOF4. Now here you have XeOF4 and adjacent one you have 2HF. They are in the product side, but here they are in the reactant side. Therefore what you have to do, reverse equation 1. Hope you are able to understand this. Here they are on the product side, so reverse that. What you get? You get XeOF4 plus 2HF gives us Xef6 plus H2. I am not mentioning gas to save time. Let us move to the next one. So here you can observe very simple XeOF4 and XeOF4 here, right? Now let us calculate this. So what you have, keeping that equation 2 as such, XeOF4 plus Xef6 gives us XeOF4 plus XeO3F2. Fine. So what will happen if you are reversing this? K1 now will become 1 by K1. Why? Because you are already familiar. If you reverse the equation, what will happen? It will become 1 by K. And second one, you can take it as K2 as such. Nothing is done for this. Now, underline this or circle this XeOF4. Then comes 2HF. Other side XeO3F2. Circle that, and H2O. Now you want this required equation, so we have circled this, so we need not do anything with this, but the other one gets cancelled out. XeOF4 here, XeF6 gets cancelled out. Therefore we can write like this: the products will be XeO3F2 plus H2O. So you got the required equation, and now you have to multiply this 1 by K1 into K2, nothing but K2 by K1. So what is this? Option B is your answer. Hope you have understood this. Very simple. It is similar to your questions in enthalpy of thermodynamics. Hope you have understood this. Copy the solution and let's move to question number 19. Next, let us solve question number 19 here. A mixture of 0.3 mole H2 and 0.3 mole I2 is allowed to react in 10 liter flask at 500 degrees. So they are asking for this particular reaction, equilibrium constant is calculated as 64. They are asking what will be the unreacted iodine at equilibrium. First and foremost thing, write down the equation. H2 plus I2 gives 2Hi in the gaseous state only. Initial number of moles is 0.3 H2 and 0.3 I2. Product is not formed, hence we can write it as 0. Next, number of moles at equilibrium. Number of moles at equilibrium. So here we can take it as 2x. Why we took 2x? Because if the concentration, or you can say that number of moles 1 means x, to coefficient if they put 2 means you will take it as 2x. Next, you know that 0.3 minus x and here 0.3 minus x. So from the starting material we have to subtract the number of moles of the product. Next, we need to calculate the concentration at equilibrium. Because this is in number of moles, but they have given you the volume also, hence we know that formula for the concentration, or you can say active mass, is equal to number of moles by volume. We have done this earlier also. So what will be the number of moles? 0.3 minus x. And volume 10 liters. Here also we have 0.3 minus x by 10. And this one is 2x by 10. So hope you have understood this. Next one, what will be the formula for Kc? So you know Kc is equal to the concentration of the products to the power of coefficient divided by the concentration of reactants. We are familiar with this. And here they gave Kc value as 64. So let us substitute that. Kc 64 is equal to Hi concentration is nothing but 2x by 10, and we know here we have square, hence we have written square, divided by H2 concentration 0.3 minus x by 10. So 2 times we can simply write it as 0.3 minus x by 10 square. Hope you have understood this. Next step. See, to remove this square, to calculate x, send this to other side. What we get? Root 64 is equal to 2x by 10 into this. Let us take it to the, so numerator what we have, 10 by 0.3 minus x. So cancel 10, and what is root 64? 8. So 8 is equal to 2x by 0.3 minus x. This on cross multiplication we get 8 into 0.3 minus x is equal to 2x. So what we have, this is nothing but 2.4 minus 8x is equal to 2x. Send minus 8x to other side, we get plus 8x. Therefore 2.4 is equal to 10x. Hence x is equal to 2.4 by 10, nothing but 0.24 molar. Hope you have understood this. We got x value as 0.24 molar. Now what is the question? Calculate the amount of unreacted I2. So nothing but at equilibrium, what is I2? Let me erase everything. Hope you have taken this. So here they are asking, so amount of unreacted in terms of moles, therefore 0.3 minus x. What is x here? 0.24. So 0.3 minus 0.24. So 0.06 moles. So hope you have understood this. So we got the answer, nothing but 0.06 moles. So copy the solution and let's move to question number 20, the last one. So copy the solution, I will give some time. Next, question number 20, the last question of this session. The equilibrium constant of a reaction is given as 300, that is Kc. Now, if the volume of the reaction flask is tripled, that means you have made it into 3. If at all, initially it is 1 liter, now it has become 3 liters. So now, what is the equilibrium constant for this? If volume is tripled, 100, 300, 250 and 150. See, no need of any calculations, because we know that equilibrium constant Kc does not depend on volume. So it is independent of volume. Even though if it is tripled or doubled, what will happen? Now Kc remains constant. So therefore they have Kc as 300. Therefore if volume is tripled, also K dash you can take and write it as 300. So Kc remains constant because it does not depend upon the volume. So answer will be 300 as such. Hope you have understood this. In this session we have done with the question number 11 to 20, and previously we have done 1 to 10. So in the coming class we can continue with question number 21. Hope you have understood this. If at all you have any doubts, you can put a message in the comment section. Thank you so much.